Fluids include anything that flows. That's the literal meaning of the term fluid, in fact. Nearly all life on Earth lives in a fluid environment. There are two principal fluids that are important: air and water. But sometimes life creates its own fluid environment. Despite water being a liquid and air being a gas, as fluids, the two have much in common. We touched upon this briefly in the biophysics module when we spoke about hydrostatic skeletons. We're going to introduce some basics here about fluids, paying attention in particular to what makes fluids different from solids. So, for example, solids deform under forces. Stress imposes strain, and vice versa. And we quantify this relationship using the stress-strain curve, which gives us the fundamental property of solids, elasticity. Fluids also deform under forces, but in a very different way. So, for example, a force can set a parcel of fluid into motion. Rather than strain, an imposed force imparts momentum to a fluid, which does not happen in a solid. Living things also interact with fluids at surfaces, and when fluids flow past a surface, momentum is transferred between them. How effectively this occurs is embodied in a fundamental property of fluids, viscosity. Fluids have viscosity, while solids do not. As you watch the lectures to follow, I'd like you to keep 5 things in mind. First, I want you to keep in mind both the similarities and differences in how solids and fluids transmit work through themselves. I'd like you to keep in mind the concept of shearing flow, and how this relates to the transfer of momentum within fluids, and how this relates to the fundamental fluid concept of viscosity. Third, I'd like you to keep in mind the fundamental similarities between the stress-strain curve that is used to define elasticity and the shear stress-shear rate curve that defines viscosity. Fourth, I'd like you to think about how principles of conservation of energy can be used to analyze the physics of fluid flows. Finally, and fifth, I want you to keep in the back of your minds how fluids can be designed to behave in unexpected and adaptive ways.